Okay, so this video is just going to be a review of the review sheet that you were given before spring break. Since spring break has passed between now and the test, I thought it probably helped just to review the review. However, it's going to be kind of hard to see if you don't actually have one. So you need to make sure that you have a copy of it in front of you. Question number 1, it says to sketch the graph of f of x equals 2 natural log x plus 1 plus 2. So in order to sketch that graph, I'm going to go ahead and plug that into the calculator. But what I want to do is I'm going to plug in the original graph, which would just be natural log of x. So I'm going to plug that in first. And I would hit graph and just see what that looks like. Hold on just a second, my graph is zoomed weird, so I'm going to hit zoom 6, which will take it to a standard graph. And it would look like that. Now that would be the original graph. And if I were to look at my table, if you'll remember, natural log only has one exact critical point. That's the same critical point that all the logarithms have, which is the point 1, 0. You can see that right there. But the other critical point that we use a lot of times with logarithms is the critical point 8 and 2. It's actually 8, 2.0794, etc., but that's pretty close. So I'm going to use the two critical points if my original graph, I'm just going to call it g of x, would be natural log of x. Then I would have two critical points, the point 1, 0, and the point 8, and it's approximately 2. If I am going to transform this into this, that 2 in front is a vertical stretch by 2. So I've got vertical stretch by 2 and a vertical shift up 2. And then this inside is a left 1. Remember, these first two values affect your y values because they're both vertical, and this affects your x values. So I would take my original point 1, 0. The x value is going to be affected 1. It's going to go left 1, so that will now be 0, because left 1 will be minus 1. It's going to affect my y values first by multiplying by 2. 0 times 2 is still 0, and then up 2. So this point 1, 0 has now become the point 0, 2. So I could go ahead and draw that. And this point, my x value is going to be affected by 1, so that would now be 7. And my y value, I'm going to multiply by 2, which will give me 4, and add 2, which gives me 6. So now I have the point 7, 6. This also tells me that my new asymptote is going to be at -1, so I know that I have an asymptote here. So this is going to look something like that. And of course, your sketch doesn't have to be perfect, but I named two critical points just like it asked me to. Now remember, these are all approximate because this is natural log. If it was a common log, then I would have two actual critical points that I could find. But with natural logarithms, I end up having to estimate. Okay, next on problem number 3. My first thought on problem number 3, or on any of these, is going to see if you can get like bases. Now, I don't think I can turn 243 into a base of 9. I know that 9 squared is 81. 9 to the 3rd power is 729, so that's already too big. But I might be able to convert them both into something with a base of 3. I know that I can turn 9 into 3 squared. Let's see, if I have 3 to the 4th power is 81, 3 to the 5th power, 3 to the 5th power is 243. So I'm going to take this first one and call it 3 squared. Don't forget the 3x plus 4 was already up there and it was already grouped. So it's going to be 3x plus 4 equals 3 to the 5th power, and the x plus 2 is grouped. Now once I have that, I have like bases, which remember I can disregard those bases. And I'm left with 2 times 3x plus 4 equals 5 times x plus 2, which now just becomes a simple equation that I can solve. I distribute my 2 and get 6x plus 8, distribute your 5 and get 5x x plus 10. Now I'm just solving for x. I'm going to subtract 5x from both sides and subtract 8. And you end up with x equals 2. So the key to that was to first get like bases. Looking at problem number 4, it's also similar. I'm going to see if I can get like bases in this case. Now I have 1/4 m minus 7 equals 16. So I'm going to write 1/4. Instead of it being 1/4, I could write that as 4 to the negative 1. And then I have to remember that the m minus 7 was out there. 16 can be rewritten as 4 squared. I'm going to move this out of the way and just do it on a piece of paper now. So I have 4 to the negative 1, it's minus 7, equals 4 squared. I have like bases here, so I can disregard my bases. I have negative 1, m minus 7 equals 2. Negative m plus 7 equals 2. So m equals 5. All right, problem number 5, a couple of different ways that I could solve this. I could, again, find like bases on this, or, as with all inequalities, I could do this in my calculator and do the left side in y1, so 10 to the x plus 3. And then do 100 to the x minus 1 in my y2. And then I could graph that, and I could actually just look for where one is greater than the other. Now in this case, my second one is not going to show up unless it's not going to show up where they cross because of the 100. It's a lot bigger. So I'm going to zoom out. See if I can see it that way. There's the first one. Let's see. I'm going to change my window. Oop, still thinking. I obviously don't need anything less than 0. It doesn't look like I'm going to need much of this. Sorry. Going to change my window a little and see if I can see these better. Okay, there goes my first one. And there goes my second one. It doesn't look like these are ever going to cross. So let's go ahead and see if we can solve this one by hand. If I can get like bases, then I can disregard the bases and just solve the inequality. So I'm going to change this to 10 squared. Now I have like bases. I can disregard the 10s. And I'm left with x plus 3 is greater than 2x minus 2. So let's see, I'm going to add 2 to both sides and subtract x. And I end up with 5 is greater than x, or x has to be less than 5. Number 6, they're just asking me to rewrite this in logarithmic form. It's currently written in exponential form. I need to rewrite it logarithmically. Remember, the base is still the base. So this becomes log base of 5, because that's my base. The answer becomes the argument, so 1 over 625. And the exponent is the answer. It's negative 4. So that's just rewriting. Number 7 says evaluate this. Log base 6, I'm going to rewrite it in case you can't see it. Log base 6 of 6 is 8. Well, remember, with logarithms, the 8 gets to come to the front. So that's 8 times log base 6 of 6. And if the base and the argument are the same, like this, they equal 1. So the answer to number 7 is just 8. And number 8, it says evaluate log 8 of 128. So they're asking me 8 to the what power equals 128. I can either just try to figure it out in my head, or remember, alpha window 5 gives me my log base button, and I can just plug that in the calculator. And I get 2.33333. Now this time, on number 9, they've asked me to solve this. Log 64x equals 2/3. The first thing I'm going to do is rewrite this exponentially. Remember, your base is your base. Your answer becomes your exponent, and your argument is your answer. So now all I have to do is plug that in my calculator. 64 raised to the 2/3 power. And you get 16. Problem number 10 is an inequality. I'm going to plug it into my calculator. I can use my log button here. So I'm going to use alpha window 5 for my log base. Somehow I got here on line 2, so I'll go ahead and put the second one in. 3x minus 2. And I'm going to go ahead and make one of them bold. I'm making my second line bold just so that I don't get confused when they come up on the screen which one's which. This is log base 4 of 2x plus 5. I'm going to have to hit zoom 6. All right, now when it draws, there's my first line, and there's my second line. Now I'm looking for where the first line is less than the second line. Now right here, this is all above it. So I'm going to zoom in over here to the right a little bit, because I think that's where it crosses over here. I think it looks like it was crossing over here somewhere. Because I'm looking for where that first line, the thinner line, goes below, is less than or equal to the bold line. Okay, it still looks like it might be crossing right over here. I'm going to see if I can do an intersect, second trace, intersect. Yeah, it intersects at x equals 7. So let's see. I'm going to zoom my window out just so you can see it better. If it's going to cross at x equals 7, I'm just going to go between 0 and 10, and I'm going to count by halves just so we can see it a little bit better. Let's see. This is all above the y-axis. So I'm just going to draw this. I'm just changing the window a little bit so you can actually see it a little bit better now that I know that they cross at 7. I was looking for where that thinner line goes. The thinner line is on bottom, and it happens somewhere around 7, so over here. And then for the remainder of the graph, it's going to be below. So x, it happens at 7. So remember, it's an inequality. And so starting at 7, and for the remainder of the graph. So you could write it as, now it has an equal sign underneath it. So I could write it as bracket 7 to infinity. I could write it as x is greater than or equal to 7. Either one of those would work. Okay, on problem number 11, we're going to use those log properties. And for right now, I'm going to pretend that I can't use my calculator, that these are the only numbers I know. I know log base 5 of 2, and I know log base 5 of 3. I also know log base 5 of 5. Because it equals 1. They don't ever give you that one, but I do know it. So in this case, I need to rewrite 18. Well, in terms of a 2 and a 3 and a 5, if I can do that, I can rewrite this as log base 5 of 9 times 2, which is the same thing as log base 5 of 3 squared times 2. Now I'm going to use my log properties and expand this. That would be log base 5 of 3 squared plus log base 5 of 2. In this case, the 2 gets to move to the front. So I have 2 log 5 of 3 plus log 5 of 2. Well, I know what these two values are. They gave them to me at the beginning. So I know it's going to be 2 times 0.6826 plus 0.4307. I'll plug that in my calculator. 2 times 0.6826 plus 0.4307. And I get 1.7959. Now, number 12 is going to be a similar problem. I'm going to have to rewrite this in terms of the logs that they gave me. They gave me 2, 3, and I remember 5. So I could rewrite this as log 5 of 5 minus log 5 of 2. Because remember, if it's division, I can expand it with subtraction. Well, that is 1, and log 5 of 2 is 0.4307. So I just plug that in my calculator, 1 minus 0.4307, and you get 0.5693. All right, so now these are all using those properties of logarithms to condense and solve. So the first thing I need to do on number 13 is I need to get all of my logarithms on one side. So I'm going to take this log and move it over. And I'm going to rewrite this and do it on a separate piece of paper so that you can see it better. All right, so now I'm going to have 0, because I've moved that logarithm over, equals 1/3 log base 5 of 64 plus 1/2 log 5 of 49 minus log 5n, because I moved that from the other side, and so now it's negative. Okay, now I'm going to condense this using my log properties. So I need to take anything in front and move it back to be an exponent. So that means I now have log base 5 of 64 to the 1/3 power plus log base 5 of 49 to the 1/2 power minus log 5n. And that still equals 0. Now the whole goal here is to solve for n. 64, if you remember, this is 64 to the 1/3 power is the same thing as the cube root of 64. So I could go ahead and simplify that, or if I wanted to plug it in my calculator, I could do 64 to the 1/3 power, and you get 4. So I'm going to rewrite this. 0 equals log base 5 of 4 plus log base 5 of 49 to the 1/2 power 7 minus log 5n. So I just simplified my exponents there. Now, I have logarithms separated by addition, which I'll put back together with multiplication, and subtraction, which is division. So I'm going to write log base 5 of 4 times 7 divided by n. So that's 0 equals log base 5 of 28 over n. Now, I'm going to rewrite this exponentially. Once you get it all down to one logarithm, you're going to rewrite it exponentially. So my base is 5 to the 0 power equals 28 over n. Well, anything to the 0 power is 1. So I've got 1 equals 28 over n. Multiply both sides by n to clear the fraction, and you get n equals 28. And that's your final answer for number 13. Let's try number 14. It's a similar problem, except this time my logarithms are all on the same side already. I have log base 6, 5 minus 2a minus log base 6, 3a equals 1. Since my logarithms have the same base, I can condense them. They're currently separated by subtraction, which means when I put them together into one logarithm, it's going to be by division. So I got 5 minus 2a over 3a equals 1. Now I'm going to rewrite this exponentially. Your base is your base, your answer is your exponent, and your argument is your answer. 6 to the 1 power is just 6. If you want to look at it as 6 over 1 so that you can just cross multiply, you can do it that way. And I end up with 18a equals 5 minus 2a. So 20a equals 5. A equals 1/4. This is your final answer. That's your final answer for number 14. Number 15, again, I have to move my logarithms to get them all on the same side. So I'm going to go ahead and start as if they've already been moved. Log base 3 of x minus 3 plus log base 3 of x plus 2 minus log base 3 of 6 equals 0, because I moved that from the other side. Now I've got to condense this logarithm. These two are separated by addition, which means we'll multiply, and this one's by subtraction. So to write one logarithm, log base 3, I'm going to multiply x minus 3 times x plus 2. I'm going to divide that by 6 and set it equal to 0. I'm going to have to FOIL out the top. And now once I have it down to one simplified argument like this, rewrite it exponentially. So 3 to the 0 power equals x squared minus x minus 6 over 6. Anything to the 0 power is 1. Cross multiply, clear the fraction. And I got 6 equals x squared minus x minus 6. Now, I've got x squareds and x's in the same problem. And then move everything to one side and factor. X squared minus x minus 12, which does factor, is x minus 4, x plus 3. So x equals 4 and x equals negative 3. Now, x can't be negative 3 because if I plug that back in here, negative 3 minus 3 gives me negative 9, and I can't have a negative argument. So x equals 4 is the only answer. And that was for number 15. All right, number 16. Whenever I see a problem like number 16, my initial thought is going to be try to get like bases. But there is no way to rewrite 80 with a base of 7. So the only thing I can do is write log on both sides. So I've got log, and I'm going to use common log. Log 7 n plus 3 equals log of 80. Now the whole point in doing that is so that I can take what's written in the exponent and move it to the front. So I'm going to have n plus 3 log 7 equals log 80. Now this is a little tricky. Don't let this throw you off that this is written behind this because it's just a distributive property. I'm going to distribute this log to both pieces. So I'm going to have n log 7 plus 3 log 7 equals log 80. Now the whole purpose of this problem is to get n by itself. So I'm going to come over onto a piece of paper and write this. So I have n log 7 plus 3 log 7 equals log 80. And I'm trying to get this n isolated. So I'm going to subtract 3 log 7. And I get n log 7 equals log 80 minus 3 log 7. I can't subtract those two things. Just have to write it like that. And now I'm going to divide by log 7. And I get n equals log 80 minus 3 log 7 divided by log 7. And that's it. That's your exact answer. You can plug that into your calculator and get your decimal approximation if they ask for it. Next problem is very similar. Number 17. I have 3 to the n power equals 6 to the n minus 2. First, you want to try and write them with like bases. You cannot in this case. So I'm going to write log in front of both sides. The whole point in doing that is so your exponent can be moved to the line. So now I have n log 3 equals n minus 2 log 6. Which is like the last problem, had that distributive property. It looks funny because it's backwards from what we're used to, but still distributive property. N log 6 minus 2 log 6. Now, this time I have 2 n's, and I need to get my n's together. So I have an n here and an n here. So I'm going to subtract this one or move this one over. So now I have n log 3 minus n log 6 equals negative 2 log 6. Now, this is a tricky little step right here. I have 2 n's, and I can't combine these two because the arguments aren't the same. The only thing I can do is undistribute that n, or factor out n. It's like a GCF. So now I have n in front of parentheses log 3 minus log 6 equals negative 2 log 6. Divide both sides by log 3 log 6. And that's your final answer. So I end up with n equals negative 2 log 6 over log 3 minus log 6. That's my exact answer. They asked for a decimal approximation. You just plug that in your calculator. Problem number 18 on the review, again, is an inequality. I would just plug this in my calculator. Just be aware that you're going to have to adjust this because it's 30. So let's see, I'm going to plug 5 to the 4x minus 1 in the left side, and 30 in the right side. I really don't need it to be bold because I know it's going to be a straight line. I know that my window is going to have to be changed, so because it has to go up to at least 30, so I'm going to go up to 40 just so I can see it. Okay, I choose. There's the exponential. There's the line. I'm looking for, according to my question, which is right here, I'm looking for where the exponential, I don't know if you can see that. There you go. Looking for where the exponential is less than 30, so I'm looking for all of this piece. And remember, you're looking for the x values. So I need to know this intersection. So I'm going to do an intersect. It intersects at 0.778. And don't forget, these exponentials, they go to infinity. So I'm going to go from negative infinity to 0.778. And none of it's included because my original sign was just a less than sign. All right, now number 19 asks me to express log 15.5 in terms of common logarithm. This is the change of base theory. Remember, it's always argument over base. This is going to be log 5 over log 15. And then it says approximate its value, so you have to plug it in your calculator. All right, this next one is asking me to solve this. Now, I have to remember that natural log is log base e of x plus 4 equals 4. So to solve it, that would be e to the 4th equals x plus 4. Subtract 4 from both sides. So x equals e to the 4th minus 4. That's the exact answer. You plug it in your calculator and get the decimal answer. And then the final one for 21, I plug into my calculator again. I have e raised to the negative 3x is less than or equal to 18. I'm going to graph that. There's my exponential. I am looking for where the exponential is less than or equal to 18. So I'm looking for the intersection point and continue on down. So let's see. My intersection happens at negative 9.634. And remember, this is an exponential, so it's going to infinity. So it's less than or equal to, so it's going to be a bracket, negative 9.63 all the way to infinity. And that is your final answer for the review.